Hi guys, still in IQ Maths, and I hope that you're all well. Today, the million-dollar question is: what is a derivative? Okay, um, I feel that as mathematics students, we should sometimes understand what we are doing, as opposed to remembering things like parrots, because we are not parrots. So, for those of you who would like to really understand what you're doing when it comes to differential calculus, then I think this will be the right video for you to watch. So let us start by defining the average gradient. So the average gradient by definition is the average gradient, the average gradient between two points on a curve is the gradient of the straight line joining the 2 points. Is the gradient of the straight line joining the 2 points. Okay. Now, let's further impose a few other things. So, consider a function f of x, okay, where f of x is some curve, and I would say let a be the point. Okay, a is a point on the graph. Let a be the point on f of x, and a is the point x and f of x. Okay, so f of x corresponds to the y value, and that's obviously the x value, because f of x is the function value. So cool, a is this point here. Okay, and then we're going to say let b be the point which is h units away from a. Okay, so if b is h units away from a, and a is this point here x and f of x, then b must be the point x plus h in x value. So this is like your new x value, because it's h units away from the point A. And in terms of y value, it should be f of x plus h, because this function value corresponds to this x value. This function value corresponds to this x value. So that's why the arguments in the function change. Okay, the arguments mean what's in the brackets. So let's get a little diagram going here. So this refers to point B. So to get a little diagram going on here, we will draw our function. So this is like your function f of x. Okay, and let's suppose that this is the point A. Okay, and we said let A be the point. Here's it here. X with corresponding function value f of x. Okay, remember this is just like y and x. And we said let B be a point which is h units away from A. So B was the point x plus h with corresponding function value f of x plus h. And this is like your new x value here and your y value. Okay, so we got a straight line. Okay, that suffices. And we noted that B is 8 units away from H. The distance here between B and A has to be H units. Now, by definition, what is the average gradient? The average gradient between 2 points on a curve is the gradient of the straight line joining the 2 points. So we have 2 points on some curve, A and B. Okay, the curve is f of x. And we'd like to find the average gradient between the 2 points. So all we have to do is find the gradient of the straight line which joins the 2 points A and B. And we know a formula for that. The formula is given as average gradient is equal to m, sometimes we use small m to denote a gradient, and we know it's simply a change in y over a change in x, so in other words, y2 minus y1 over x2 minus x1. Okay, let us call this point here our x1 and y1, our x2 and y2. Take the coordinates and substitute the formula. So y2 is f of x plus h, and y1 is f of x, so it's minus f of x, all over x2, which is x plus h, minus x1, which is x. Okay, so we can do a bit of simplification here. We can see that this implies that m, the average gradient, is f of x plus h minus f of x. And if you simplify here, you'll have x plus h minus x, positive x and negative x cancel, you're left with h. So this is the formula for average gradient. Okay, now you may ask, what does this have to do with the derivative? Well, let's see what happens as h becomes smaller. Okay, so let's consider a point through A, but now it goes like this. We're going to reduce the size of h each time. So let's consider this point here. Okay, and this will be our new h. Okay, this will be our new h. So we're going to just look at what happens when h becomes smaller, when we decrease the distance between the point A and B. In other words, we are making h become very, very, very small. So, okay, that happens. Let's use another color. Okay, so we will use another point. Hopefully you can see that this is purple. Okay, so this becomes our new h here in purple. So it's much smaller than the one in black. Let's use another color, light blue will work. Okay, up to here, let's say. And as you can see, that h is smaller than the other h's. And if we have to use, if you continue this process, we make h very small. Eventually, the straight line becomes tangent to the curve at the point A. I hope you guys can see that. I shall illustrate this. Okay, so if we make h very small, eventually, okay, let's put more tidy. So if we make h very small, eventually this straight line becomes a tangent to the curve at the point A. And here's this line here. Try to draw it to the best of my ability. Um, so what happens is this. As h tends to 0, in other words, h becomes extremely small, then the line in the diagram becomes a tangent to the curve at point A. And this really represents a gradient at a point. And why is this representing a gradient at a point? Because previously, when we considered 2 points A and B, we had an average gradient. Because by definition, the average gradient between 2 points in a curve is the gradient of a straight line joining the 2 points. In the case where h becomes really small, we find that the straight line only passes through 1 point because it becomes tangent to the curve at the point A. So really then what average gradient measures at that point, as h becomes really small, is the gradient at that point. So that's why I say, and this really represents a gradient at a point. So this is what the derivative does for us. So we say that f prime of x, the first derivative with respect to f of x, is given as the limit as h approaches 0, as h gets very small, of f of x plus h minus f of x all over h. And this is where the derivative comes from. This really represents a gradient at a point. So that's what the first derivative is. I hope that makes sense, guys, and this is your geometrical understanding of it. Thanks, guys. Let me know how you feel.